Hello, my Algebra 2 students. It's day 2 of our exponents unit. What we're going to focus on today are negative exponents. So the first part is you want to make sure that you know the rule for negative exponents. So in general, if I have, I don't know how I want to say this, a raised to the negative x power, that is the exact same as if we take the reciprocal of a, and now we can raise it to the positive x power. So that's your first rule that I want you to keep in mind, all right? Now, the second way I'm going to write this is that sometimes it's already in fraction form. So like, let's say we have a over b like this, raised to the negative x power. If you already have it in fraction form, you're actually allowed to flip that fraction over. So b over a, and now it would be raised to the positive x. So if it's already in a fraction, you're allowed to just flip the fraction over and raise it to that power, because this is the reciprocal. So same thing. A, since it's over 1, that is your reciprocal. Okay, so with that in mind, let's actually put it to practice. So for the first one, if you have it raised to the negative third power, that's your rule right there. So you can make it 1 over 2 to the positive third. And then because it's a number, go ahead and actually cube it out. So 2 times 2 times 2 would be 1 over 8. Something to keep in mind when it's just plain old numbers on your calculator, you can do 2 and raise it to the negative third power, and it would give you this. But if you math frac it, there you go. There's that 1/8 right there. I don't know how well you can see it, but you get the deal. Okay. All right. Whoops. Let me slide that out. All right. So here's one where it looks like the second example. So you can take, and if it's already a fraction, when you take the reciprocal, just flip it over. So now it's 4 over 3 raised to the positive second. All right, from here, you actually have to square it. So squaring this means you're squaring the top and you're squaring the bottom. Or you can think about it as the whole thing gets multiplied by itself, which is 4 squared and 3 squared. So you're going to get 16 and then over 9. Right. So if you need to, pause the video, try the last one. So hopefully you tried it. Let's quick check. Flip it over. So it should be 2/5 raised to the positive third power. So now 2 cubed is 8. 5 cubed is 5 times 5 times 5 should be 125. All right. So when it's just one single fraction, I think it's easiest to do it like that. When we hit this next part, I'm going to show you a couple different methods, because sometimes you might see it one way versus another, but then I'll tend to kind of stick with one way to look at it. All right. So for this first set, when I said method 1, it says blank of any expression raised to a negative exponent. So if it's raised to a negative exponent, we would take the reciprocal. Of any expression raised to a negative exponent. And then I'm just going to say simplify. But it could be then multiply, then whatever, and simplify. So we'll say then ... simplify. All right. So what I mean by that, this is raised to a negative exponent. So if I take the reciprocal of x to the negative second, that would be 1 over x to the positive second. But then I still have that fourth power out there. All right. If I raise everything in here to the fourth, I would get 1 to the fourth, and then x squared raised to the fourth. 1 to the fourth is just 1. Power raised to a power, we would multiply. So this would give me x to the 8th. Right. With the second one, raising this to a negative power, taking the reciprocal, this is where it gets a little funky, because the whole thing's not raised to a negative exponent. So if I want to take the reciprocal of just the top, I can, even though I'm not really suggesting this, so just roll with me for a moment. I can take the reciprocal of just this part, which would be 1 over x squared, and then still over an x to the fourth. You can kind of tell that I don't love this because it now makes it a complex fraction. But if I wanted, I can say, all right, if it's this top part divided by the bottom part, I can write that differently. This guy divided by that guy. All right, think of our last unit. Keep, change to multiplication, flip that on over. So if I multiply by the reciprocal, now the x to the fourth goes into the bottom piece of it. All right, so this would be 1 over x squared times 1 over x to the fourth. I would get 1 on the bottom, or excuse me, 1 on the top. And then when you're multiplying bases, I would add exponents. So 4 plus 2 would give me 6. Okay, not the worst, but not my favorite. Let's look at the second method. Second method is to actually do any operations first. And now when I say that, I mean specifically like exponents, right? So essentially like distributing exponents. And then now take the blank for any expression with negative exponents. So now take the reciprocal. So in the first one, rather than dealing with the negative first, if I look at the exponents, power raised to a power, if I raise this to the fourth power, as long as I remember we're multiplying, it's negative 2 times 4, I get negative 8. So now that it's got a negative exponent, I would take the reciprocal, and it becomes 1 over x to the positive 8. That tends to be a little bit simpler than what we did the last time, because those two are the exact same problem. So same result, just different way to get there. All right, with this one, there is no negative exponent to distribute or any exponent to distribute. So when I say let's take the reciprocal, what I want you to think of is this is already in fraction form. So if I want to take the reciprocal of something that's in the numerator, it just means it's going to move to the denominator. That positive x to the fourth in the bottom won't go anywhere. So I'm going to take this and drop it down to the bottom and make it a positive x to the second, which just leaves me a plain old 1 in the top. Now I can multiply those together, which means I add the exponents. 4 plus 2 would give me x to the sixth. Now, of course, there's actually other ways than this. I could have subtracted exponents because I was dividing and then taken the reciprocal. So that just goes to show you lots and lots of ways. I didn't say these are the only methods. These are some of the methods. I'm going to try to focus on this one, where if there's an exponent raised to everything, I'm going to deal with that first. And then if there's any negative exponents, I'm going to focus in on just them, and I'm going to move them to the other part of the fraction. So keep that in mind as we go on to the next page. So here, there's no exponents to distribute. Let's see if I can zoom in just a little bit. No exponents that I need to worry about in terms of distributing, but I do have negative exponents sprinkled within the fraction. So let's circle anything raised to a negative exponent. So that's the a to the negative 1. That's the b to the negative 3. All right, we're going to switch the locations. So something from the top needs to go to the bottom. Something from the bottom, that's going to come up top. Those that were raised to positive exponents don't go anywhere. So I sometimes joke this is like changing up seats for naughty kids. I don't move the good kids. I just switch around the naughty ones. So keep the 36 up top. Keep the b to the fifth up top. But now b to the third will join it because that becomes positive. 27 stays put. This a squared stays put. And that a to the negative first comes to the bottom and joins it as an a to the positive first. All right. And now just clean up what we can. So let's see. 36 b to the fifth times b to the third, add those together. So b to the eighth, and then 27, a squared times a to the first, that'll give me a to the third. So can you simplify anything else? Well, yeah, 36 and 27. 36 is the same as 9 times 4. 27 is the same as 9 times 3. So the 9s will go, and now I'll fully be left with 4b to the 8th over 3a cubed. All right. This next one, everything's raised to a negative second power. So I have a choice. I could flip everything in the inside, make it a positive second, or let's try to focus on what we said for back here, which was let's distribute the exponents and then we'll mess. Okay. But I want to remember all the exponents on everything right now, if I don't see it, are just ones. So this is like a 3 to the first. This is 6 to the first. This is z to the first. Okay. So if I use that rule, distributing the exponent, power raised to a power, we multiply. So this becomes 3 to the negative second. Negative 2 times negative 2, that becomes x to the positive fourth. Y cubed raised to the negative second power, y to the negative 6. This gives me 6 to the negative second power. This gives me z to the negative second power as well. All right, circle anybody that needs to move. So that 3 is going to have to shift. The x stays put. Y is going to shift. 6 shifts. The z shifts. Okay. So the only thing that stayed put was x to the 4th. Everything else is moving. So 3 comes to the bottom as 3 squared. Y to the positive 6. 6 to the positive 2nd. Z to the positive 2nd. So these guys went down. These guys went up. All right. Now that everything's raised to a positive exponent, let's kind of clean things up. So 6 squared is 36. X to the 4th, z to the 2nd. 3 squared is 9, and then y to the 6th. And then the only other thing that can simplify here is this. So I can either think of it as just 36 divided by 9, or I can think that 36 is 9 times 4, cancel the 9s, and I'm left with 4x to the 4th, z to the 2nd, y to the 6th. All right. So many methods will get you there. You just have to decide on one. All right. Number 8. I like this one. This one's a little bit tricky because it's not quite the same as the others. Let's save this guy for class together. All right. What I'd like to look at next, the ones at the bottom. So for number 9, it says use the properties of the exponents to rewrite it in the form of kx to the n. So that just means a constant times x to some power. Then evaluate the expression for x. So we got 2 parts to it. All right, the first part, we want to rewrite this guy so that it's in that format. All right, so if I have 9 over 2x to the negative 3rd, okay? If I distribute the exponent, that's going to be 9, and then 2 to the negative 3rd, x to the negative 3rd, which means both of those babies are going up top. You could have right here just shifted that whole thing up. All right, that's going to give me 9 times 2 to the positive 3rd times x to the positive 3rd. All right, that leaves me a 1 in the denominator. So I can now just kind of ignore that denominator. So remember, exponents first. So that's going to be 2 times 8 times x cubed. That'll give me 72x cubed. That is my k times x to the n. So k x to the n power. All right, there's part 1. Part 2 now says plug in x and let's see what happens. All right, so if we do 72 and we plug in negative 1/3 and then cube it. You can grab your calculator at this point, or you could cube it on your own. So negative 1 cubed will stay a negative 1. 3 cubed. So 3, I guess I could show it first if I really want to be thorough. All right. 3 cubed should be 27. Oops. So whatever this is going to give me. Oh, geez, 72 and 27. They both have 9 in common. So if I take out 9 times 8 and 9 times 3, the 9s will go. This, I believe, is going to give me negative 8/3. Now, just to be safe, I'm going to grab my calculator and try that. All right. Let me get off of that guy. 72 times, let me slide it over, negative 1/3, and now raise that to the 3rd power, and then math frac that guy. Woo, negative 8/3. All right. So sorry, I was trying to make it darker and it wasn't helping any. I was going the wrong direction. All right. Let's save part B for class. Okay. Thanks so much, guys. See you soon.